Welcome all. And this topic was supposed to be presented yesterday because of some confusion with the time zone actually and time slots actually. So this I couldn't join at the appropriate time. So I'm just starting with this presentation for today actually. It was rescheduled for today and I'm just starting. So today's topic is AI techniques to improve the software testing. So that is the key topic for this presentation. Sorry. Everybody will have heard this topic or term AI. What is this word all about actually? Have you given any insight? Have you given any thought on what this word definitely means from your perspective? AI, AI, AI. Whether you hear any industry, it's not just IT. When you hear any day-to-day activity, it is being driven by AI these days actually. So what is this word all about? Artificial intelligence. It's basically planning and diagnosis and software engineering and testing. So artificial intelligence in terms of planning and diagnosis and software engineering, we call it as testing. So this is something, basically what I'm trying to show is like testing, which is planning and diagnosis and testing. These all three things are amalgamated into one area actually. And that is where this term AI comes into picture. It is a new buzzword spreading its wing in every significant industry. It's just not IT. Automotive industry, rocket industry, automobile industry, hotel industry, hospitality, everywhere you see artificial industry. It enables the computers to perform the tasks that would have called for intellect and input in an ancient scenario. The surface area for software industry has never been bigger. Therefore, software industry designers and testers will look to AI to solve most of the software challenges. So the introduction of artificial industry will help the testing overcome those testing and QA challenges. So now you might be thinking, that's the same thing which happened when manual testing was being driven by automation testing. Automation testing was a buzzword which was driven to solve the testing and QA challenges. So what will AI come into picture? What will AI do specifically, which will help in overcoming the testing and QA challenges? I'll tell you. Testing, you see, is important. There are quite a few software development paradigms, and all of them recognize the importance of testing. And there are several types of testing: functional testing, non-functional testing, and under functional testing, there are different areas. Non-functional testing, there are different areas. And other than that, there are black box testing, white box testing, everything. So if you've done ISTQB certifications, you will know what are the different testing areas we are talking about actually. I've been working in testing industry for last 24 years now. So I know when I started my career almost in 1998, 1999, there was no testing paradigm at all. We used to have a development project, and fairly at the end of the cycle, development cycle, 10% of 5% time we were devoted to testing actually. That's what used to be the testing in 98, 99. But it has evolved slowly and it has gone into a separate niche skill now actually. And nowadays we estimate testing as part of the overall development life cycle. So testing is very, very important actually. You see programmer on the left side, he writes the programs, follows the specs, and the goal is to fix bugs. And tester runs the test, follows the test specs, and gets the defects actually. So how do you handle a bug? Bugs are reported by tester. For example, screen A crashed on step 13 of the test suite 4. This is just some simple things like how you handle a bug. And prioritized bugs are assigned to the programmers. Suppose you find a bug, there are severity 1, severity 2, severity 3, and there are prioritized bugs. And those prioritization and severity are driven back to the programmers to fix it actually once you find the bugs. And bugs are diagnosed, and what caused the bugs, that is the root cause of the issue actually. And bugs will be fixed by the developer. So this is typical defect life cycle which I'm talking about here. And why is debugging a hard? Because whenever you find a bug, you give it to a developer. Developer finds it difficult to debug the bug actually. He doesn't know how to fix it. He doesn't know sometimes how to debug the bug, how to fix it, how to resolve it, and he turns it back to the developer defect tester, saying the defect is not reproducible, or defect is hard to fix, or defect can't be fixed in a short amount of time. Do you all face these kind of explanations from the developer or the business analyst whenever you find a bug? I have found it in numerous occasions actually. And I am always heard from the developer that let the tester provide more information. I found that whatever defects we find out, normally the developer says or the tester hasn't provided the relevant information, and probably they reject the defects most of the times actually. So that is where I'm trying to introduce the concept of the AI actually here. You run a test suite, find a defect, and diagnose and fix the defect. That is done by the developer. Intermediate, if you introduce AI techniques, you'll compute the diagnosis, plan the next steps, and diagnose and fix the bug actually. So what will AI do is you'll compute diagnosis and plan the next steps, and this cycle can be repeatable. This cycle can be repeatable, and productivity will be more actually from the testing perspective. So what I'm trying to here show in this slide is the TDP mechanism, test, diagnose, and plan mechanism, which is being used by the AI, where you continuously run the test and the developer and to fix the bugs. The AI technique is there to compute a diagnosis and plan the next set of tests actually. So tester runs a set of plan tests, the tester finds a bug, and AI, which is the middle box, which is this green box, the AI generates the possible diagnosis, and if there is only one candidate, it will pass on to the programmer, else the AI will plan new tests to prune the candidates and find as many permutation combinations and give it back to the developer to fix the bugs actually. So diagnosis will, the middle box in the AI area, which was shown in the previous slide, shows find the reason of a problem given the observed symptoms. Requirement is knowledge of the diagnosis system, which is given by the experts and learned by the AI techniques. In the next slide, I'm trying to show 3-4 AI techniques which we have used actually in the past and which I've used extensively in my projects actually, and which will give more the hit ratio of finding a defect, diagnosing the defect from that perspective. One of the popular techniques of finding a defect using an AI is model-based diagnosis. Here, a model is how the system will work. It will say, infer what went wrong. An example is from the automobile industry actually. If this is a typical if-then statement. If the battery is okay and ignition is okay, then start the engine. Else if the battery is not okay or ignition is not okay, then it will not start the engine. So what if the engine doesn't start? The vehicle will not start actually. That's what will happen normally. Where all is MBD, that is the model-based diagnosis applied. In printers, it has been used. In vehicles, it has been used. Robotics, as well as spacecraft. Here, I'm just explaining the 4 areas where it is extensively used, but there are n number of areas actually, which I can say. In spacecraft, it is being used. In automobile, it is being used. Printers, robotics. And in the IT world, most of the programs or products, it is being used extensively from that perspective. Software is difficult to model. Why? Because the need to know how the software should behave, and specs are complicated to model actually. So static code analysis ignores the runtime, and which includes the polymorphism and instrumentation. I don't know how many of you have heard about Zoltar. Zoltar had constructed this model from the observations way back in 2011 actually. And observation should include execution traces, functions visited during execution, observed outcome, and a weaker model. So OK function 1, and the outputs are valid, and the bug entails that at least one component was not okay. I'm going a little bit technical to show you what the MBD and the Zoltar mechanism had shown in the past actually. Execution matrix. A key component in the Zoltar is the execution matrix. It is built from the observed execution traces. So you develop the different functions to find the probability of finding a bug. For example, in the observation 1, you have created 8 functions to find a bug actually in one level. In observation 2 also, you can't, in the MBD analysis or the Zoltar analysis, there are different areas of functions which can find and the probability to find a bug actually. In observation 3, if you say 1, 1, 1 here, but the probability of finding a bug is 0. So the more probability of finding a bug, that is the probability which is shown in the bug. Actually, we have found a bug from that perspective. So observation 1 is F1 to F5 to F6, and you find a bug. Observation 2 is F2 to F5, and you find a bug. Observation 3 is you will not find it because it's a okay happy path scenario. F2 to F6 to F7, A2, you will find a bug actually. Diagnosis is the hitting set of conflicts. In every bug trace, at least one function is faulty. Observations, which I showed in the previous slide, is F1 to F5 to F6, you find a bug. F2 to F5, you find a bug. But conflicts, if it is F1, F5, F6, it might be okay. And F2 and F5, it might be okay. So the possible diagnosis is F5, F1, F2, F6, F2. So this is a bit complicated in terms of the functions which has been shown in the earlier mechanism in that perspective. So software diagnosis with Zoltar, what he said was bug report through the Zoltry, a set of cognitive diagnosis. You find a bug actually, and you prioritize the diagnosis. Wherever you're finding the bug, you prioritize those diagnoses and ignore the other ones actually from that perspective. So once you have developed the technique, you will find that you will have a possible set of possible diagnoses, and you can suggest a new test to prune the candidates. Instead of running all the tests where there's a possibility of finding the bug or not finding, you can just concentrate on the priority of possible diagnosis where you can just find the bugs. So that is the AI engine which will be developed from the MBD or the Zoltry mechanism. So objective of the Zoltry or the MBD is to plan a sequence of tests to find the best diagnosis with minimal tester actions. Okay, plan a sequence of tests to find the best diagnosis with minimal tester actions. And there are different areas from that perspective also, which I'll show in the next 3 slides actually. One is the HP mechanism or HP technique, which we call the highest probability. You compute the probability of every function CI and the sum of those probability of candidates containing the CI. And plan is to check the most probable functions. For example, in this slide, there are different probabilities it can see. So F5 is the probability is 0.4, sorry. F1 the probability is 0.2. F2 is the combination of 0.2, 0.4, and F6 is 0.4. So if you combine all this, the black areas show that this is the areas which has to be stuck from that perspective, and AI has to catch these functions probability. Consider only functions where CI with the probability is less than 1. So where I am saying F5, F1, F2, F6, which had the probability of less than 1 actually, and test the closest functions from this set. Second is and third is the earlier one was the lowest cost. First one was the highest probability. Second one was the lowest cost. Third one is the entropy based. Entropy based, this is a set of components. The set of candidates that assume alpha will pass and the set of candidates that alpha will fail. So what is the set? And you'll get a third set of candidates that are indifferent to alpha, that is pass and fail. So probability of alpha will pass is the probability of candidates in alpha plus actually. So test with the lowest probability which will give the highest information gain. So here in this, test those functions which will give the highest probability gain actually, information. And there's a fourth category called as the planning under uncertainty. So outcome of this test is unknown. We would like to minimize the expected cost. To formulate it, this is formulated as the Markov decision process or the MDP method also actually. So states are set of performed tests and their outcomes, and the actions will be the possible test. And current solver, we will use myopic sampling to find this planning of or the MDP method to find the probability actually. So if you compare all these techniques, that is the highest probability, lowest cost, entropy, and the planning under uncertainty, which is the MDP. So preliminary experimental results will show a synthetic code, which is the setup of getting the random call graphs with 300 nodes. What I'm showing is in the previous slide, these are called as different areas are called as nodes. So generate a random call graphs with 300 nodes, inject 10 to 20 random bugs into the program actually, and generate 15 random initial tests. So run until a test with probability is greater than 0.9 is found. So the results will be out of 100 instances, how many greater than 0.9 probability is found actually. So if you compare all these 4 techniques, whereas MDP, LC, entropy, and HP, come up with a count graph actually, or create a probability matrix and find which one will be more effective from that perspective. And always what I have found is I have tried my softwares using all these 4 techniques, whether it is MDP, LC, entropy, and HP, and I found MDP is most effective from that perspective. So what it shows is this sample is based upon from one of my project is HP and entropy perform worse than LC and MDP. This one is worse than MDP and LC. And probability based HP and entropy perform worse than the cost based approach also. MDP, which considers cost and probability outperforms the others. So always MDP technique is the best in terms of the AI techniques of preliminary experimental results. And 20 bucks is more costly for all algorithms than the 10 bucks actually. That's the end goal which has found from this. But always what I found is MDP is the best technique from that perspective. This one is preliminary experimental results. We call it in N units terms actually. The real code, well-known user. It uses C#, testing framework actually. Setup was generated using the call graphs with almost 302 nodes actually. When I created this N unit using C#, almost 302 nodes were created. I randomly injected almost maximum of 30 random bugs to generate a 15 random initial test actually. And our results were created out of a possible 110 instances from that perspective. And this is from that 110 instances. Similar results were I found out, and the cost increases with the probability, which I found actually. So if you see which is the best effective technique here is MDP, because HP, the probability is very, very high and the cost is very, very more. Which is giving the lowest cost and the probability, that is MDP always. Result is the test, diagnose, and plan paradigm. AI diagnosis observed work with MDD algorithm, and AI plans the further test to find the correct diagnosis. Empowering the tester using AI, that is what is required from that perspective. So the bug diagnosis is done by the tester. It is not AI is testing on its own. A combination of tester plus AI is where the bug diagnosis is done from that perspective. So a combination of tester plus the AI techniques which can be used will give better diagnosis from that perspective. So the integrating the AI-based system is quite a few vendors in open market offer AI solutions for testing, and to choose a system and do a POC. The system will have an API to communicate with your existing applications. Ask your development team / vendor to do an integration, and it will not involve integration of various tools as depicted in the next slide actually. So when I talked about the four specific techniques, whether it's MDP, entropy, low cost, or the probability, HP probability, there are tools now, AI tools to create those softwares. But when I started almost way back in 2011, 2012, not much of the AI tools were prevalent in the market. So I designed some tools on my own, worked upon it from that perspective. Okay. So what this shows is there are various areas like software configuration management, server logs, source codes, developer, QA tester. You jot down, you come up with the AI engine which is prevalent in the market, or create from your own and inject those systems, inject those AI engines into your application or the product. So integrating the AI-based systems, you can have that AI systems can be amalgamated into a system from configuration tool perspective, build tool perspective, that is the database systems, test automation tools, reporting tools, their Tableau, Power BI, test management tools like ALM, Jira, and create a dashboard from that AI-based tool actually. You inject the AI-based tool into a system, come up with the better diagnosis, and create a dashboard. That is what this slide is showing about from that perspective. So analytics generated with the AI tool is, AI tool gets various data feeds. You can get the data from ALM, Jira, configuration tools like Visual Source, build tools, database systems, SQL, Oracle, test automation tools, Selenium, Supertest Mocha, or robot framework, or reporting tools, and come up with a dashboard. So it can be used, the analytics generated from AI tools can be used in asset analytics to capture the various matrices around analytics and provide recommendations on improving the leverage from various individual assets. Staff analytics assist understanding the distribution of capabilities and specific skills among the complete team, just not including the client's own staff and vendor resources, but other tools, track the real-time progress being done on workforce transformation initiatives, predict the resource needs for ongoing and upcoming programs upfront. For example, I used in my last project almost 6 months back, we reduced a team from almost 32 manual testers to almost 18 manual testers actually. That we did the staff analytics using the AI-based tools. Customer analytics is customer feedbacks from various social channels can be used from that perspective. Delivery analytics, present various analytics for improving the testing delivery and trends to all possible levels and help the testing teams to make decisive calls. Right sizing the solutions, whether combination of various analytical tools, whether you need all the solutions which are there as part of the architecture also, that can be analyzed actually. And predictive analytics is the last area where it provides predictive positive views for all key dimensions associated with the success of any specific projects. Benefits of using AI in testing is early completion of software testing lifecycle. It saves time, but definitely better coverage. Tests suggested by the system shall ensure the optimal code coverage. Even the test coverage you can see, just not code coverage, will help in getting the overall quality software with less time and effort, will help in creation of reusable prediction models. Unattended execution, you can just create a bad job and let it run in the backend actually. And in case of failures during the test execution, AI system shall execute recovery routines and achieve the unaided execution. And you just run it and probably leave it in the night time and come in the morning and you'll find that everything is being generated. No need for a huge amount of manual effort as well as server areas actually. Will help in integrating the source control systems, build servers, environmental systems, and the test management software and cognitive systems. Right now, when I talked about those 4 or 5 areas or tools which I had developed in the past, I had created from scratch using SHYAM. But now there are different areas, tools prevalent in the markets. There are Apple tools, AI-based tools from Apple Tools, Source Labs, Retest, Test.ai, TestIM, Eggplant. I have specifically used Eggplant and Retest from my projects actually. Eggplant, the reason being, we had a product called which used to run on Citrix actually, and Eggplant had customized a AI tool for our needs way back in 2016-17, and I had extensively used from that perspective. Even Retest, I have used it actually. I'm not just advocating use it, but you can try other tools also which are present. For my projects, this was specifically applicable, and I have used it extensively. And I had specifically inbuilt AI tools also using the techniques which I mentioned in the past. So I had 3 levels of AI tech tools which I could have used and have used extensively in my projects. I've done a case study that is the CAFM implementation when I was part of the Dell services. CAFM is the Computer Aided Facilities Management. When we did that testing, just using manual testing and automation, the defects were very high actually, but we couldn't find, most of the defects were rejected, and there was no predictive outcome from that actually. When the tool which I developed, it resulted in effort savings actually from that perspective. I ran both the tools simultaneously and found out that the more the defects which I found from AI tools, it helped in quicker resolutions and effective predictivity actually. And the implementation was far superior, better. Similarly, in terms of a healthcare project where I did a reproductive medicine implementation, etc., same without the tool and with the tool, I did a comparison. It was more beneficial when I used the AI techniques specifically. So the conclusion is, with the amalgamation of AI in test execution and data analysis, testers can permanently do away with the need to update the test cases manually, continually, and identify controls, spot links between defects and components in a far more effective manner. So you'll find this little bit moving or fuzzified with the automation area also, but AI definitely is far better, far productive, far predictive, and far giving better outputs than the automation. That is what I'm trying to show from this presentation. I received continuous feedback for last 4 or 5 years actually by using the tools which I've used in my projects. And these are some of the feedbacks which I've used. I'm sharing some of the feedback which I've received from my stakeholders, CEO, CIO, and CTO. Recommendation from my perspective and based upon my analysis, based upon my usage of AI is, let's start using AI in testing as much as possible. It is definitely the buzzword. When I started my presentation, I said it is being used probably right now in every part, every day-to-day activities of life. But let's start using AI in testing as much as possible if you haven't started using it from that perspective. Yeah, that's all from my side. Actually, I'll pass it on for the question answer if any audience has. If they don't have right now also, basically they can reach out to me using the email ID or the Twitter handle or the LinkedIn. I just wanted to share from that perspective. But I'll pass it on to the audience in case they have specific questions for me for this presentation.
Thank you. So, question? Yeah.
Hello, thanks for your presentation. Please correct me if I'm wrong. Is it true that there are some tools or services that can gather information from different sources, and it has inside some artificial intelligence that can predict bugs or can report bugs? And if it's true, please can you give some names of these services of tools?
Yes, definitely. I showed you 6 tools actually, which are prevalent actually. Some of the components in Eggplant and Retest, they definitely have that analysis done actually from that perspective. And they can give it back from that perspective. You'll have to configure it based upon your need, depending upon the server and the architecture configuration. And it will give you the dashboard and from the predictive analysis. Definitely.
Okay, thank you very much.
Thank you. No question? Okay, thank you so much.
Thanks a lot. Yeah, I really appreciate if you still have any questions which you want to ask and couldn't ask, reach out to me on my email, Twitter, and LinkedIn, and I'll be happy to address them.
Yeah.